Today's video lesson deals with perpendicular lines. So much like yesterday's lesson that was parallel lines and identifying parallel lines based on slope, we're going to identify perpendicular lines based off of their equations by looking at the slope as well. So as a reminder, perpendicular lines are lines that intersect to form right angles. They intersect at 90 degrees. And if we're talking about the slopes of perpendicular lines are opposite reciprocals. Okay, so slopes here are opposite reciprocals. Well, what does that mean? Opposite means the opposite sign. Okay, so the opposite of 5 is -5. The opposite of -2 is +2. So we're going to take the opposite sign. And then the reciprocal means we're flipping. Okay, so if we're looking for opposite reciprocals, 5 and -1/5 are opposite reciprocals. So the opposite of positive is negative. And if I flip 5, which technically would be 5/1, it's going to be 1/5. So it went from positive to negative, and we flipped the numerator and denominator. Okay. Now technically, with these opposite reciprocals and these perpendicular slopes, the product is technically -1. So if I multiply 5/1 times -1/5, well, we can cross cancel the 5s, we're just left with -1. Okay, so that's another way that you can check about opposite reciprocals. Product is -1. Okay, so here's another example. 2/3, okay, positive 2/3, the opposite reciprocal of that would be a negative, flip it around, 3/2. And then the last example written here is -1/4, its opposite reciprocal would be a positive 4/1, or just 4. Okay, and friendly reminder, vertical and horizontal lines are always perpendicular to one another. So here's a model. There are 3 different equations that are written here and graphed. And we want to determine, oh, there's actually 4. One's up here. I missed it. We want to determine which lines are perpendicular. Okay, so each of these is represented down here on the actual graph itself. So a y equals 3 is a horizontal line that goes through the y value of 3. Technically, horizontal lines have slope of 0. The equation x equals -2, that's another special equation. That's a vertical line. And the slope of vertical lines, hopefully you remember, is undefined. Okay, so that x equals -2, that is graphed right there. Okay, now there was a little note up here. Vertical and horizontal lines are always perpendicular. So take a look at just the first 2 lines that we looked at and are graphed. Y equals 3, that's a horizontal line. X equals -2, that is a vertical line. They intersect at 90 degrees. Okay, so these 2 are perpendicular to each other. Now let's take a look at our other 2 lines. We've got y equals 3x. Okay, our slope is 3. So that one is going to be right here. Y-intercept is 0, slope is 3. So that's this line. And then we have y equals -1/3 times x minus 4. Now this isn't really any form in particular, but if we distribute through slope-intercept form, it would say y equals -1/3 x plus 4/3. Well, our focus is on our slope, and our slope there is -1/3. Okay, so that's going to be this line right here. Well, if I compare the slopes, obviously those slopes are not the same, and we're not intending them, or we're not wanting them to be the same, because then we would be talking about parallel lines. Are these 2 slopes opposite reciprocals? Well, the opposite of positive is negative, and if I flip 3/1, I get 1/3. So technically the 3rd equation and the 4th equation are in fact perpendicular to each other, and take a look at their graphs. They do intersect at 90 degrees. Okay, so it's all going to come back to looking at the slope, identifying the slope, and checking for opposite reciprocals. So similar to yesterday, the first 2 examples, we want to determine which lines are perpendicular by identifying the slopes of our lines. So A is a special one. Again, this is a horizontal line. Therefore, our slope is 0. Okay, because this could be written as y equals 0x minus 4. B, this is point slope form. And hopefully you remember from previous units and from yesterday's lesson, the slope is what's right in front of the parentheses there in point slope form. I'll write it again. Okay, so our slope is right here. So it means the slope of B is 5. All right, taking a look at C, if it's an x-only equation, that's a vertical line, which means the slope here is undefined. Okay, so undefined for C. And for D, we have a nice slope-intercept form. Slope is -1/5. Okay, so keep in mind, we're looking for opposite reciprocals. Well, remember, again, vertical and horizontal lines are perpendicular to one another, always. So A and C, A is horizontal, C is vertical, therefore A and C are perpendicular. Okay, they intersect at 90 degrees. Let's take a look at B and D. If I compare these slopes, we went from positive to negative, and from 5/1 to 1/5. Well, that looks good to me. B and D are also perpendicular. Okay, we can also do the check. Does 5/1 times -1/5 equal -1? Okay, because that was another little tip here. The product of the slopes is always -1. Well, when we do that, the 5's cross cancel, we end up with -1. So, boop, we're good. Take a look at number 2. We're looking to find out what the slopes are and determine which lines are perpendicular to each other. So A is in slope-intercept form. The slope is -1/2. B is also slope-intercept form. The y-intercept would be 0, but we don't really care that much about that. The slope is 1/8. C is point slope form. Y minus y1 equals m times x minus x1. So here is our slope. The slope is 2. D is in y equals mx plus b, or slope-intercept form. Slope is -8. Let's look for opposite reciprocals. -1/2 and 2, let's take a look at those because, I mean, they're clearly going to be potentially going together. Went from negative to a positive, from 1/2 to 2/1. So A and C are perpendicular to each other. And B and D, well, let's take a look at those. 1/8, so it's positive, went to a negative, and the 1/8 turned into an 8 over the invisible 1, so B and D are also perpendicular to each other. Okay, so we had 2 pairs of perpendicular lines. A and C are perpendicular, they intersect at 90 degrees, and B and D intersect at 90 degrees. Okay, and we can do the check. -1/2 times positive 2/1. 2's cross cancel, negative times a positive is a negative, and we're just left with 1, -1. And 1/8 times -8 over the invisible 1. 8's cross cancel, positive times a negative is going to give us a negative, and we're just left with 1's, so -1. Okay, so both of those do check out. And last but not least for today's lesson, which line is perpendicular to y equals -5x plus 1? Well, if we need it to be perpendicular, my original slope is -5. We want our perpendicular slope, this upside down capital T, which actually makes perpendicular lines here. That represents perpendicular. Our perpendicular slope would therefore need to be, it would need to go from a negative to a positive, and we would need to make it go from a 5 over 1 to 1 over 5. So we're looking for the slope of our perpendicular line has to be positive 1 over 5. Well, when we look at our answer choices here, in A, our slope is 5, so that is not correct. In B, our slope is 0. That is not correct. C, our slope is 1/5. And that's what we were looking for. Let's just check out D. D is negative 1/5. Well, we flipped, but we didn't change the sign. So because of that, not the correct answer. Okay, so our answer here is C, because negative 5 and positive 1/5 are opposite reciprocals. Okay, so that's our key. Opposite reciprocals for the slopes of perpendicular lines.